Hello everyone, today we're going to be going over the area of a sector formula. Now, this formula is ultimately going to be A is equal to theta r squared over 2. But why is this the case? Well, you might want to realize that this theta here is going to be in radians, because that's the kind of nature of the things we are working out with radians, like the area of a sector. But then, how do we do this? So, you might remember that we determined the area of a circle is pi r squared because a circle is of the same area as a triangle with its radius on one side and its circumference on another side. That's because a triangle is made up of infinitely many lines like this, which when rolled into circular shape will make up a circle of radius r. Now, say we want to find what portion of a circle is from the angle theta. So, Q. What is the portion of a circle from angle theta? Well, we know that one portion of a circle is when theta is 2 pi. Therefore, theta over 2 pi must be equal to the number of circles. You might also realize that this 2 pi here is similar to the fact that there are 2 pi circles. 2 pi radians in a full circle. But I'll touch on that later. So we know that theta over 2 pi is the number of circles theta represents. And since we know that the area of one circle is pi r squared times 1 for there being number of full circles. Say we wanted to find the area of a third of a circle. Which of course has a certain angle in radians. First try and figure it out, then I'll write it down. Right, it's 2 pi over 3 radians. And with radius r. And we want to find the area of this object. Well, obviously, since it's a third of a circle, the area would be pi r squared times 1/3, because it's a third of the area of a circle if it's a third of a circle. So, why is this the case? Firstly, we can get it from the method that the number of circles is going to be equal to theta over 2 pi, so this number will be 2 pi over 3 radians over 2 pi, because that's the angle, and that's the angle per full rotation, so this will give you the number of full rotations. So that's one way of figuring it out, since A is pi r squared times theta over 2 pi, for theta over 2 pi being the number of full circles there are. You can cancel out the pi on both sides, and you'll get that the area of a certain sector is theta r squared over 2. So that's one way of figuring it out. And the second way is if we go back to our triangle model, and we can just try and use the fact that since this will be equal to the largest ring of any sector, so like say for a half circle, the rings are going to look like that, almost like a rainbow, and the furthest out ring is going to be half of the circumference. Or we can realize that this is related to the arc length formula. L is theta r. So this will be theta r for a given r of a sector and a certain angle, such as pi radians. So if this is the outermost ring, and this is theta r, we want to find the area of this triangle, which will be equal to the area of the sector. For example, since area is half times base times height, it'll be equal to half times r times theta r, or theta r squared over 2. And thirdly, if you remember the method that we used to find the area of the circle before with the parallelogram, the one with infinitely many pizza slices of such a circle, we got that area of a circle from the fact that we knew that the two sides of the parallelogram, the two long sides, they will sum to circumference. And if we look at a sector, we know that since this is just the outside bit, and these are just made of the outside bits of the circle, we can say that such a rectangle now, they would approach summing to arc length, which would be theta r. So since these sides of the rectangle will sum to arc length theta r, each one must be theta r over 2. And since nothing changes about the radius when we go from a circle to a sector with the same radius, if we want to get theta r squared over 2, we're assuming the radius is constant, so the radius will be the same here. So we just need to find the area of this rectangle with the side r and the long side theta r squared over 2 from all the slices inside this rectangle. And since the area is base times height, we'll know the area of this rectangle, which is equal to the area of the sector, is going to be theta r squared, or theta r over 2 times r, which is theta r squared over 2. So that's 2 or 3 ways you can figure out that the area of a sector is going to be the angle of the sector in radians multiplied by the radius of the sector squared, and finally divided by 2. It is crucial that you remember this angle is in radians, and you'll need to convert to radians if you want to get it from something in degrees. Alternatively, you can use the fact that the area is going to be pi r squared times the number of full revolutions. And since there's 360 degrees in a full revolution, you just want to take the number of degrees divided by 360 to get the number of full revolutions. Say for 720 degrees, which is 2 circles, there'd be 2 full revolutions and the area would be 2 pi r squared. Or say for a quarter of a circle, the angle theta would be pi over 2. So it would be pi over 2 r squared over 2, or pi r squared over 4, a quarter of a circle. Alright, so just what's crucial to know is that the area of a sector A is equal to theta r squared over 2. That's all. Thank you for watching. Next video, I'm going to be going over the trigonometric ratios, sine, cosine, and tangent, and what they mean.